Our next topic, parallel forces and couples. In our previous lecture, we have been studying about the forces acting at one point only. But sometimes the given forces have their line of action parallel to each other. A little consideration may show that such forces do not meet at one point, though they have some effect on the body on which they act. The forces whose lines of action are parallel to each other are basically known as the parallel forces. Now, these parallel forces are basically two types. One is the like parallel forces and another one is the unlike parallel forces. The forces whose lines of action are parallel to each other and all of them act in the same direction as shown in the figure, they are basically the like parallel forces. This one basically. And the forces whose lines of action are parallel to each other and all of them do not act in the same direction means their direction of the individual may differ. The such forces are the unlike parallel forces. Here it is shown. Now next topic is the findings of the resultant force of such parallel forces by analytical method. Before that, it is to be mentioned that the resultant of the parallel forces is basically found out by two methods. One is the analytical method, which I just going to teach you, and the next is the graphical method. In analytical method, we will take two forces, parallel forces obviously. One is P and another is the Q. Say this is force P which is acting at point A, and another parallel force Q, say Q, which is acting at point B, and P is parallel in the direction AL, and Q in the direction and magnitude BM. Now join line AB and apply two equal and opposite forces, say S at point A and B. At point A, it is to be in the direction BA, and that is represented magnitude and direction by AD, and at point B the S is applied in the direction AB, which is represented in magnitude and direction by line BE. Now complete the parallelogram. Say this is ADFL, whose magnitude is AF, and next is, sorry, this is BM, BMGE, and its diagonal is the BG. Now the resultant forces of this parallelogram ADFL, its resultant force P1 say P1 will be obviously represented by the diagonal A, and in the case of parallelogram BMGE, the resultant will be say Q1, and which is obviously represented by diagonal BG. Now if you produce the diagonal FA and BG, they will meet at point O. They will meet at point O. Now draw OC, draw OC, which is parallel to AL and BM, and that will meet the line AB at point C. Now transfer the resultant forces P1 and Q1 represented by the diagonal AF and BG of the parallelogram from A and B to O. So shifting P1 from point A to O and Q1 from point B to O, and the now resolve the force P1. You may get the force S at point O and the force P along OC. Similarly, whenever the resultant Q1 is resolved, again it will give S and Q in the direction OC. Now at point O, the two forces S are same in magnitude and opposite in direction. So obviously there will be no effect at point O. The resultant of the two components along along OC will be equal to P plus Q. P plus Q. Now from the two triangles OCA and ALF, from the two triangles OCF and ALF, they are similar by construction. So OC by CA equal to AL by LF, but L by LF equal to P by S, force P by force S. So P dot CA equal to S dot OC. Similarly, from two triangles OCB and BMG, you may found out that q dot q dot cb s dot oc. So it may be concluded that p dot ca equal to q dot cb. We have considered here, for the sake of simplicity, only two forces P and Q, but this principle may be extended for any number of forces. Now, if it is given to find out the resultant of two unlike parallel forces by analytical method, in that case the methodology obviously will be the same. And now we will listen what to do in such cases. Say this is point A and this is point B. Force P at A and Q at B are acting. It is already given that they are parallel and unlike, so obviously their direction will be in opposite sense. P is represented in magnitude and direction by the line AL, and Q force is represented in direction and magnitude by the line BM. Now join the line AB. Apply to equal and opposite forces each equal to S at point B in the direction AB and at point A in the direction BA. Let these forces represented by side AD and BE. Since these forces are equal in magnitude and opposite in direction and have the same line of action, so therefore these forces will have no effect on the body. Now complete the parallelogram AL FD and BM GE. The resultant forces of this parallelogram will be represented by their diagonal AF and BG. The resultant force of the parallelogram ALFD is the P1 and the resultant of the diagonal BMG is Q1. P1 is represented by AF and Q1 is the BG. Now produce this diagonal such that they can meet at point O. Now draw OC. Now draw the line OC parallel to the force P and Q, or parallel to the line AL and BM. Such that the line OC will meet the line AB at C. Now transfer the resultant P1 and Q1, represented by the diagonal AF and BG of the parallelogram, from A and B to O. P1, this is P1. This is Q1. Now dissolve the force P1 into two components, S parallel to AD, S parallel to AD, and P in the direction OC, P in the direction OC. Sorry, we just make correct the direction of P1 here. The direction of P1 will be in that direction. And now dissolve the force Q1 at O, two components, into two components, S parallel to BE and Q in the direction OC, and Q in the direction OC. A little consideration may show that two equal and opposite components equal to S at point O will have no effect on the body. The resultant of the two components along OC will be equal to P minus Q, and parallel to the original direction of the forces P and Q. We know that two triangles OCA, that is the this one, and FDA is the this one, are similar by construction. So OC by AC equal to FD by AD, that is equal to P by S. So P dot CA equal to S dot OC. Similarly, from two similar triangles OCB, that is the this one, and BMG, that is the OCB and BMG. Similarly, you may get Q dot CB equal to S dot. Of the resultant force is same as that of the greater component. Our next topic, the couples. We have seen in our previous lectures that if two equal and opposite parallel forces, that is equal and unlike forces, are acting on a body, they don't have any resultant force parallel to the given forces. Thus, we may conclude that no single force can replace two equal and opposite forces whose lines of action are different. Such a set of two equal and opposite forces whose lines of action are different form a couple. So, the keywords of couple is two equal force, and the second one is the opposite in direction. So two equal force, they must be opposite in direction and their line of action are different. So this set is can form a couple. So we may define that couple is a set of point 1 and point 2. So basically this is the couple. A couple is thus unable to produce any translatory motion, means the motion in a straight line, but a couple produces rotation in the body on which it acts. So the next important point about the couple is that it cannot produce translatory motion, but it can produce rotational motion on the body on which it acts. So this is the main features of couple. Now the simple example of a couple may be the forces applied to the key of a lock in winding it up and the forces applied to the key of a lock while locking or unlocking it. So this is the very simple example we are following from our childhood. This is the example of couple. Now, arm of a couple. Arm of couple. The perpendicular distance between the line of action of the two equal and opposite parallel forces is known as arm of the couple. So, in the beginning of this discussion, we have already mentioned that the couple is a set of two equal and opposite forces. Now, the perpendicular distance between these two equal and opposite forces is called the arm of couple. Next, the moment of a couple. The moment of a couple is the product of the force, that is one of the forces of the two equal and opposite parallel forces, and the arm of the couple. So mathematically, moment of couple mathematically can be expressed as m equal to p dot a. So this is basically the product of the force and the perpendicular distance, that is the arm of couple. Now, classification of couple. Classification of couple. Couple is basically classified into the two categories depending upon their direction in which couple tends to rotate the body. So, depending upon the direction of rotation, couple is basically classified into two categories. One is clockwise couple and the next one is the anti-clockwise couple. The clockwise couple again considered as positive and anti-clockwise couple is considered as the negative. Now if we try to figure out the clockwise and anti-clockwise couple, you may find out that, say this is P, perpendicular distance between them is A. So the rotation of this couple in this direction, and this is basically the direction of clock. Direction of clock means the arms of the clocks basically rotate in this direction. So this is the clockwise couple or the positive couple. Similarly, if we want to try to figure out the anti-clockwise couple, then this is 4p and this is the perpendicular distance, so their rotation will be in this direction, and this is obviously the opposite direction of clock, means the arms of the clocks rotate in which direction? that is different or that is the opposite of this direction, then obviously it may be called the anti-clockwise couple or negative couple. Next, the characteristic of a couple. A couple, whether it may be the clockwise or anti-clockwise, they may have the following characteristics. One is the algebraic sum of the forces constituting the couple is 0. Algebraic sum of the forces constituting the couple is 0. Say this is one couple. So if you want to take the algebraic sum of these two forces, then are equal to, say this one the algebraic sum. Then if you take this the positive in sense, then obviously this may be the negative, because this is in downward direction. Then if you take the sign convention as downward as positive, and then obviously upward will be negative. So in that case the sum of the algebraic sum of the forces will be, so P minus P, that is 0. And if you take the anti-clockwise couple, in that case also, sorry, again I am taking the clockwise. So if this is your couple, say, sorry, and if you take this one as downward, as you already have taken the downward as a positive in the previous example, then obviously this will be positive and this is the negative. Then obviously the sum of algebraic sum of the forces will be minus P plus P. Then obviously this may give you the 0. So the first features, that is the algebraic sum of the forces constituting the couple, is 0. The next one, the algebraic sum of the moments of the forces constituting the couple about any point is the same and equal to the moment of the couple. The next point, the algebraic sum of moments. This is the short form of moment, MMT. I am just using this one, so you should take it as moment of the forces about, this is the short form of about, ABT, any point is same and equal to the moment of the couple, itself. So this is the second features. Now the third point is a couple cannot be balanced by a single force, but can be balanced only by a couple but of opposite sense. Obviously the couple is the product of a force and the perpendicular distance between the parallel forces. Unlike parallel forces, then couple is P dot A whenever, then obviously you cannot replace that the product P dot A by a single force P. There must be another component, that is the distance. So couple cannot be replaced by a single force, but can be replaced or can be balanced by another couple which is positive in sense, means the direction of that couple must be the opposite. So if you try to understand that the moment of the couple, say M, then obviously you cannot replace this M by a single force P. That is not possible, but as because M equal to P dot A, P can be replaced by another force P, then there will be another component, that is A, which is not being replaced by only this force. So the words are obviously true. The moment of the couple or the couple cannot be replaced by a single force. But obviously, if there is another moment, say M dash, which is P dot A, P dash dot A, and if the direction of P dash is just opposite of P, and the magnitude of M dash is equal to M, then you can firmly say that M dash can replace the M. The next characteristic is any number of coplanar couples can be reduced to a single couple whose magnitude will be equal to the algebraic sum of the moments of all the couples. Any number of couples can be reduced to a single couple whose magnitude will be equal to algebraic sum of the moment of all the couples. Now we will take one example. ABCD on square ABCD. So this is on square ABCD. ABCD has the forces acting along its sides. In this direction 1 Newton, in this direction 200 Newton. That is 100 Newton. In this direction force P, and this direction force Q. Now find the values of P and Q if the system produces to a couple. The first question is the values of P and Q has to be find out, and the condition is that the system produces to a couple. And the second question, find the magnitude of the couple if the side of the square is 1 meter. Now the side of the square, say AB, BC, CD, DA equal to 1 meter. Then find the magnitude of that couple. Form the forces acting along the sides of the square ABCD. We know that if the system reduces to a couple, the resultant is the resultant in the horizontal and vertical direction will be 0. Therefore, resolving the forces horizontally, resolving the forces horizontally, you may have 100 minus 100 cos 45 degree equal to P. That will give you P equal to 29.3 Newton. After detailed calculation, you may have this. Again, if you resolve the forces vertically, you may have 200 minus 100 sine 45 degree minus Q, that will give you 0, then Q equal to 129.3 Newton. So the values of P and Q are now available. The P is 29.3 Newton and Q is the 129.3 Newton. So the value of P now available and the value of Q also available. That is 129.3 Newton and this is 29.3 Newton. Now our next target point is the value of the magnitude, or the magnitude of the couple. We know that the moment of the couple is equal to the algebraic sum of the moments about any corner. Therefore, taking moment about B. So, if we take moment about B, taking moment about point B or corner B, you may have M equal to minus 200 into 1 plus minus P into 1 that is equal to minus 200 minus 29.3 into 1 so 200 minus 29.3 229.3 Newton. So the value or the magnitude of the couple is 229.3 Newton meter. Unit will be Newton meter.